Question number 121. Meristematic tissue in stellar region that helps in increasing girth of a dicot tree trunk is: first option, partly primary and partly secondary in origin; second, apical meristem; third, completely secondary in origin; fourth, intercalary meristem. This question is asking about the meristematic tissue in stellar region. What is stele? If you see this diagram which I'm showing you, it is pit. Here, these are the vascular bundles, and it is the pericycle. So these three, pit, vascular bundles and the pericycle, together constitute the stele. Now, the meristematic tissue within the stellar region, it means it is talking about the cambium ring. So this is the cambium ring which is present within the stellar region, and it is meristematic. So it helps in increasing the girth of a dicot tree trunk. Yes, it helps. It is partly primary and partly secondary in origin. Yes, it is partly primary and partly secondary in origin. How? The cambium which is present inside the vascular bundle, within the vascular bundle, is primary in origin. It is called intrafascicular cambium. It is present since the birth of the plant. It appears very early in the stages of plant life. And this cambium is interfascicular cambium. It is secondary in origin as it develops by dedifferentiation of the parenchymatous cells. So it is secondary in origin. So this cambium ring is partly primary and partly secondary? Yes. Second, apical meristem? No. Completely secondary in origin? No. Intercalary meristem? No. Apical meristem and the intercalary meristems are the primary meristems. So the correct option for the given question is option number 1. Let's move on to the next question. Question number 122. Which of the following tissues is made up of thin-walled cells? First option, sclerenchyma; second, parenchyma; third, sclereid; fourth, xylem fiber. Thin-walled cells are parenchymatous cells as well as meristematic cells. The sclerenchymatous cells are thick-walled cells as they are lignified. So, the sclereid and the xylem fiber, because they are also lignified. Sclereid is nothing but a type of sclerenchymatous cells only. They are also lignified, so these two options are ruled out. Xylem fiber is also lignified. It is a dead tissue. It is also ruled out. So the correct option for the given question is option number 2. Let's move on to the next question. Question number 123. Read the following statements and choose the correct option. Statement A. The vessel cells are devoid of protoplasm. B. Vessel members are interconnected through perforations in their common walls. First option, only A is correct. Second, only B is correct. Third, both A and B are correct. Fourth, both A and B are incorrect. The vessel cells are devoid of protoplasm. It is very true. Why? Because vessels are dead. They are dead at maturity. They are devoid of protoplasm. They are lignified and they provide mechanical support to the plant. They help in conduction of water. B. Vessel members are interconnected through perforations in their common walls. Yes, it is also true. Why? Because a vessel member is a vessel element. See here, it's a vessel member or the vessel element. It is connected to the other vessel member with the help of perforations, and these vessel members together form the vessel. So this is also correct. So both statements are correct. So the correct option for the given question is option number 3. Let's move on to the next question. Question number 124. In most of the monocotyledons, first option, companion cells are non-nucleated. Second, phloem parenchyma is absent. Third, the cell wall of phloem fibers is thin. Fourth, vessels are absent. In most of the monocotyledons, companion cells are non-nucleated? No. Companion cells are nucleated in all angiosperms as they carry the function of sieve tube elements. Second, phloem parenchyma is absent. Yes, in most of the monocotyledons, phloem parenchyma is absent in the phloem. Third, the cell wall of phloem fibers is thin. No, it is not possible. Phloem fibers are lignified and they have thick cell wall. Fourth, vessels are absent. No, in all angiosperms, vessels are present. So the correct option for the given question is option number 2. Let's move on to the next question. Question number 125. Select the odd one with respect to the ground tissue system. First option, epidermis. Second, pith. Third, pericycle. Fourth, cortex. If you see the section of any stem, the outermost layer you can see is epidermis. And in the center, you can see pith. And here, you can see vascular bundles. And then pericycle. So these are vascular bundles. So all the tissues you see in the section of a stem except epidermis and the vascular bundles, they constitute ground tissue system. Epidermis is present in the epidermal tissue system. Vascular bundles are included in the vascular tissue system. So pith, yes. Pericycle, yes. Cortex, yes. Epidermis is not included in the ground tissue system. So the correct option for the given question is option number 1. Let's move on to the next question.